As we have seen, we can analyze simple circuits using Ohm's law. However, there are many circuits formed cannot be reduced to a single equivalent resistor. To analyze more complex circuits, we will make use of these two simple rules called Kirchhoff's rules. In Kirchhoff's rules, we have two rules. The first one is Junction Rule. We can define Junction Rule as the sum of the current entering any junction must equal the sum of the currents leaving that junction. For example, here, I1 entering the junction and I2 and I3 leaving that junction. Therefore, we have I1 equals to I2 plus I3. The second one, loop rule, we can define as the sum of the potential differences across all the elements around any circuit loop must be zero. For a loop rule, let's consider this circuit. From this circuit, we automatically can determine the junctions. We have two junctions, junction B and junction C. Let us choose junction C as our reference point. From here, we can determine I3 equals to I1 plus I2. And then, when applying the loop rule, we must choose a direction for traversing the loop and be consistent in going either clockwise or counterclockwise. As we traverse the loop, we need to record voltage drops and rises according to the rules shown here. Let's take a look. This is the battery, and let's say this is the loop traverse from high to low. Therefore, this is voltage drop. We have negative delta V. The second one, from low to high, this is the loop traverse. This is voltage lift up, positive potential difference. Okay, for the third one, we have the resistance here. The direction of current is to the right. The loop also traverses at the same direction, to the right. Therefore, we have a voltage drop here, negative IR. And the fourth one, we have the direction of the current with the direction of traverse loop is in opposite direction. Therefore, the voltage lift up, positive IR. Let's consider a clockwise direction. This one will be loop number 1. This one will be loop number 2. Okay, as we have just now, we need to record voltage drops and rises through each of the component. Let's consider loop number 1. We have, starting from this battery, the direction of the loop traverse from high to low. Therefore, we have negative 14 plus I1 times 6 ohm. And then, from this resistor 6 ohm, the loop traverse from positive to negative. So we have another negative 10. And the last one is on this resistor of 4 ohm. The direction of the traverse loop and the current are in same direction. Therefore, we have negative I2 times 4 ohm will be equal to 0. For loop number 2, let us start from this battery of 10 volt. Now, the loop number 2 traverses from lower to higher, from negative to positive. Therefore, we have 10 volt, and then the direction of traverse loop is the same direction with the current I on this resistor of 6 ohm. Then we have negative I1 times 6 ohm. Okay, the next one, the loop traverse, this is the third one here. The loop traverse in the same direction as the current. This is I3. This is loop. Same direction. If the same direction, then the voltage is dropped. Negative I3 times 2 ohm equals to 0. For your information, from C to D to A and to B, these are all the region of I3. From B to E to F and to C is the region of I2. And I1 only travel from B to C. The junction rule previously is I3 equals to I2 plus I1. Now we have 3 equations, and we have how many unknowns? We have 3 unknowns. Then you can do this simultaneous equation by using your calculator. Okay, let's rearrange. What do we have just now? From the junction rule, we have I1 plus I2 equals to I3. And from the loop rule, we have negative 14 plus 6I1 minus 10 minus 4I2 equals to 0. Another one, another loop, 10 minus 6I1 minus 2I3 will be equal to 0. So let us rearrange this to be like this. I1 plus I2 minus I3 equals to 0. The second one, 6I1 minus 4I2 equals to 24. The third one, negative 6I1 minus 2I3 equals to negative 10. And by this one, use your calculator to calculate the answer for I1, I2, and I3. Okay, this is a problem solving strategy for Kirchhoff's rules to a circuit. We have 6 steps here. The first one's assign labels and symbols. Second, we need to assign directions to the current. Number 3, apply the junction rule. Number 4, apply Kirchhoff's loop rule. Number 5, solve the equations by using the calculator. And number 6, check your answer. With that, that's all for chapter 6. Thank you.